Alright, here in part 2, I want to tell you where we've been so far. We did that in part 1, all these in part 1. I had actually just stopped with median, and here in part 2 we're going to start with altitude. Alright, so altitude is kind of a new word we haven't really talked about before in this video. We talked about constructing a perpendicular from a point off a line to a line, and how do you make sure you're constructing a line that goes through that point that is perpendicular to that given line. That's what we're going to need for altitude here. Altitude is just kind of like it sounds. In a triangle, an altitude is, okay, those aren't very straight lines. If this is sort of the base or the floor of a triangle, and I want to find the altitude of this triangle, it's kind of like saying altitude's like height, right? It's like trying to find out, well, how tall is this triangle this way? If I'm talking about height as straight up perpendicular. So the length of that is kind of what you could think of as like the length of an altitude. So that's why it feels a lot like this. It's like I'm going to have a line and a point off the line, and I'm trying to find the perpendicular, really the segment. Not really the whole line like we were doing before, but just the segment. But that's how I'm going to locate it. Okay, so I want the altitude from point A to side BC. Later we'll talk about how actually there's altitudes from every point to every other opposite side, but this one asks from point A to side BC. So what we're kind of estimating here is it's going to have to start through there, and it's going to have to go perpendicular to BC, so it has to go kind of this way. We're looking for a line that kind of goes through there and has to go through at A. Okay, let's erase some of that stuff. I'll leave that there so you can see that. All right, I need my tools here. I lost my tools since the last video. All right, so through point A from side BC. So again, you have to kind of ignore the rest of this triangle, like the stuff from B to A to C. These are the two segments over here. Just try to let your eyes ignore those. Alright, I need to stab at A, and then I need to make sure I cross the line here 2 times. Good. Cross the line there twice. Now I have this segment from there to there that has, if I perpendicular bisector that, it should go through A, and that will give me what I need. Okay, so stabbing, whoa, missed. Stabbing at one of those. Is this bigger than half? Not really. Let's make it bigger than half. Okay, I do my swoop here. And I do my swoop over here. This one, I think, compared to the last couple ones we did, I think this one looks a little more difficult in the context of a triangle. The last one didn't probably bother you so much, but this one's kind of a lot of clutter, so I sympathize with you there. Alright. So something like that. I can get that. Whoops, maybe one more tick that way. And I connect the dots here on the edge of this, the ends of this football. Great, but I don't care about the whole line. That's okay, you can kind of leave it like this. The answer to the question, where's the altitude, is really, it's just this segment here. You don't have to do any more indication other than just draw the perpendicular that goes, this construction is showing everybody that, yeah, that's perpendicular, and the fact that it goes through A is implied also. But really the answer to where's the altitude is just this little part of it here, in case you were interested. Okay, that one we kind of already did. I think that's just a repeat. Okay, now we're on to that sort of third Roman numeral from the front page. And we're getting some new terms here, like Incenter. What is Incenter? Well, Incenter, when you see the word Incenter, you should automatically think of, this is just a vocab sort of trivia question here. Incenter is made up of medians. The medians are the ingredient for, I'm sorry, that's really wrong. Gosh, you shouldn't let me go that far and tell you that stuff. That's horribly wrong. At least I caught myself before I did anything. Angle bisector. If I make too many more mistakes, I'll start over. But that wasn't too bad. I caught myself before I did anything. Alright. Trivia question. How do you find the incenter? You have to construct angle bisectors. That's going to be plural. The theorem, which we're not really going to prove or ask you to remember, is that if you actually found the angle bisectors of every single angle in a triangle, so here's the angle bisector of that one, here's the angle bisector of this one, here's the angle bisector of that one, it turns out that they actually all intersect in one point, and that point is called, guess what, the incenter. So again, angle bisectors, incenter, that's the association you need to make. Now, since we know all 3 of them, and you can get out Sketchpad and try this if you don't believe me, since we know all 3 of them go through the same point, really we don't need to construct all 3 of them to locate where that point is. Once we have 2, we'll know where it is. So I'm going to say 2 is good enough. So I'm going to start with C because my compass is kind of already here and it's kind of hard to drag this thing around. So let's do the angle bisector on C. Do the swoop across the two parts of angle C. Stab at one of them. Make sure that's big enough. Okay, that's good. Across that way, and do the same thing from the other side. Stab at that location right there, and swoop across. Okay, then I need to make angle bisector. Draw this angle bisector line. It's going to be something like this. Draw the line. Okay. So there's one angle bisector, the one at C. Now, the problem is, when you go to do a second one of these things, all this junk is now in your way. Let's do, oh, I don't know, the angle bisector of B, just for fun. Okay, get that out of the way. Angle bisector at B. I've changed colors with my pencil here just because, well, I can, and then you can kind of keep them separate. I have to do another angle bisector. Well, there's a lot of junk in my way now in my picture. All this red stuff is kind of visually a problem, especially now. Like at this point, I have to go across here, and I have to, I'm not stabbed right at the right point. I have to do this swoop out here in space. Actually, it doesn't seem to get too much in the way, but man, they really can. If you've tried this on paper yet, you've probably had lots of these examples where, am I really on that point? I think I'm close. It's hard to let go of this without it moving. See, I try to let go, get it right on there, let go, and it moves. Yeah, so good. And then you go to draw this line, and it's like, okay, which one of those little crosshair things am I going for? What? This thing always, but it's hard. It's harder to manipulate than a real ruler. Is that good? A good direction? No, I should probably go one tick mark further. I said one tick mark. You know what? I may just have to give up and say that's good enough. Okay, so this is an angle bisection. And I make sure I gotta, make that long enough to reach this intersection. And there it is. Can you see it? Well, if not, I don't blame you. So look closely. We're talking about where the two angle bisectors intersect. Here's the angle bisector coming out of C. Here's the angle bisector coming out of B. Actually, in this picture, it's not that bad. It really is just the two lines. There's only two lines that I've drawn here in pencil, and the incenter is technically that point right there. If I did the angle bisector at A, it should go through that point. You can do that just to be sure. This thing right here is the incenter. Now, you don't have to label it, but I'm just going to show you here because, again, I want to be able to let you see this later if you want to look back at it. Okay, great. Incenter. All right, the next one is circumcenter. Circumcenter is made up of perpendicular bisectors. Again, it's another sort of trivia term. Circumcenter is, let me write this in red. Circumcenter comes from the ingredients to make. Circumcenter is perpendicular bisectors. And just like in any normal or any other triangle, the perpendicular bisectors, I'll change colors, see what I'm talking about. Perpendicular bisector of this segment would go through that midpoint and be perpendicular, so something like that. Perpendicular bisector, this one would be at the midpoint and be perpendicular, and the third one would be something like that. Guess what? Yes, they all cross in one point. That point is called the circumcenter. Again, these are all perpendicular at those sides. Now you can tell which one I was talking about there. And I kind of drew them, sketched them here, so they kind of look like they go through midpoints. Yeah, all three of them intersect at one point. Kind of another cool property of the universe. But I would only require that you do two of them, because then I know that you know where the circumcenter is. Okay, let's do the one for BC, just because it's the shortest side, and I think my football will fit on the page if I do BC, and my compass will reach. You probably wouldn't have that problem as bad. Okay, that looks like it's going to work. Great. I'm just doing footballs here on each side. This one's not too bad. Okay, feel free to fast forward this. Watching me manipulate these tools can probably be frustrating, especially the ruler part. I really get frustrated by this ruler. Okay, that's pretty good. So there's a perpendicular bisector of BC. Great. Again, because I'm afraid my swoops are going to go off the page or my compass isn't going to be big enough, I'm going to do BA next. So I need to do the perpendicular bisector. I'm going to change colors again. Let's do BA. Is this bigger than half? Barely. Now it's bigger than half. Hopefully this will fit on the page. Keep it the same size. Stab it at A. Ooh, is that going to fit? Oh, yes it is. Okay, good. Alright, and then I Pretty darn close. I think I'm going to leave it just for the sake of time. Okay. So I kind of missed this. I don't know if I could have got that ruler any closer. So here's perpendicular bisector number 1. Here's perpendicular bisector number 2. And yes, they intersect. It's just way out there. Well, it turns out that can happen. I didn't explain that earlier. I didn't warn you of the possibility. But yes, it's entirely possible that the circumcenter is actually outside the triangle. In fact, that is going to happen whenever the triangle's obtuse. So notice we do have an obtuse triangle here. So here we go. Okay, that is the circumcenter, and it has some cool properties we'll get to later, but that's how you find it. Circumcenter, perpendicular bisectors. Okay, this looks like this video is going to have a part 3. Centroid. Well, the key trivia term that associates with centroid is medians. Medians are the ingredients of centroid. Oh, this triangle doesn't have a name. Let's call it A, B, C. It says locate the what? How come I can't draw a C? Was it? Oh, because there's a ruler in my way. Alright, this is supposed to be point C. Sorry about that. Alright, so I just need to find medians. Again, in any triangle, it turns out, we draw some random triangle. If I drew medians, so that's a midpoint, that's a midpoint, and that's a midpoint. Okay, bad sketch, because this is supposed to be a line, but anyway. If those are all midpoints, this kind of looks like angle bisectors, but it's really not. Those medians all meet in one point, and that point's called the centroid. It's got some cool properties we'll talk about later, but for now, let's just construct one. Alright, so let's do the midpoint of, I don't know, BC. Hopefully my compass is big enough. Is that going to reach? It's completely doing the splits here. I don't know if that's going to reach. Let's try it. Is that arc going to reach? If I start from the other side, B. Oh, it is. It's not very graceful, but it's going to reach. Yowza. It does. Okay. And then I connect the dots. Again, I'm just looking for midpoint here to do median. Oh, come on. That's not great. Is that going to be better? Not really. Should I give up? Oh, come on. I have a way to cheat and do this faster, but I about had it with that. Okay, but the whole point there was just to really point was to find the midpoint. No pun intended, but it actually turned out to be pretty good. And I connect that one, the midpoint of BC, I connect that to the opposite vertex, which is point A. So something like this. It's actually not bad. Connect that to A, and there's median number 1. Now, like all these multiple in one triangle constructions, I would completely do one median before I change color, spin the page, sort of, and do a totally different construction. Some people, I think, are trying to do like, oh, we'll do the football on one side, we'll do the football on the other side, then we'll locate the 2 midpoints, then we'll connect them to like an assembly line. I think that's kind of dangerous. I would advise do an entire median and then move on to do an entire another median. I'm going to do the median here. I'm going to find the midpoint on this side now because it looks shorter. Now the problem is I'm afraid it's going to go off the page. Oh no, I think it's going to work. Yes, okay, barely made it. You with your regular size paper and tools aren't going to have nearly as many difficulties. Not bad. I really just need the midpoint. Okay, I've located the midpoint and I need to connect that to, watch this, super magic extendo ruler. Woo. Yeah, is that going to do it? That's, you know what, close enough for right now because I need to wrap up this video. Okay, so I've got the median from A to BC, that's a midpoint. Median from C, well, close enough, to C to the midpoint of AB. Remember, that's a midpoint, and that's a midpoint. So that was, these are in fact medians. And guess what? Yes, this is what we were looking for, the centroid. Okay, almost done. The start of video 3 will probably finish up what you really need, and then the rest after that's just going to be me having fun. So I can't wait to start making that. Alright, see you in a minute.